Good evening, everyone. I, Ritika Jaiswal, on behalf of Concord Biotech, it's my extreme pleasure to extend a warm welcome to all the participants for this webinar. Concord Biotech is a global biotechnology and immunosuppressant leader with strong capabilities in the manufacturing of high quality APIs and finished formulations. With the presence of more than 70 plus countries, we remain committed in delivering excellence across key therapeutic areas, including rheumatology, immunology, transplantation, and nephrology, with a patient centric approach. So, it's our privilege to introduce our esteemed speaker for today's session. We welcome Dr. Vishwa Prakash Tiwari, sir. A very warm welcome to you, sir. Dr. Vishwa Prakash Tiwari, I think there's some network issue. Dr. Vishwa Prakash Tiwari, he is a renowned rheumatologist based at Indresh Hospital, Dehradun. And we are very thankful and very glad to Dr. Vishwa Prakash Tiwari, sir, for initiating this session. A very warm welcome to you, sir.
Sorry, actually, I lost. Thank you.
So, a very warm welcome to you, sir, from on behalf of Concord Biotech and all the participants. And we are very glad and thankful to you once again for initiating this academic series. And today we are doing our fifth session of this series. So thankful to you, sir, and we are very honored to have you in between us. So not taking much more time, I'll just hand over the session to Dr. Tiwari. Thank you so much, sir. You can continue.
Thank you. Thank you so much. So we will start our topic. Today's topic is just today's topic is IL-1 immunobiology. Means we will discuss the interleukin 1. Why it is important? Because in our rheumatology, or we have seen we have broadly two types of disease: autoimmune disease and autoinflammatory diseases. So autoinflammatory diseases are those diseases which are mainly running through innate immunity. So and among the we have three main innate cytokines: IL-1, IL-6, and TNF alpha. And if you want to say among these three, IL-1 is, you can say, it's fulfilling the definition of innate immunity, innate cytokine completely, like completely. So IL-1, if you understand the IL-1, then you will automatically understand autoinflammatory diseases. And what about the drugs? Unfortunately, in India, we don't have accessibility for IL-1 inhibitor. But hope so soon we will have, but to understand the IL-1 will help us to understand many diseases which is also common in India and many rare diseases which can be life-saving for a patient. So if you want to understand the IL-1, I told you innate immunity. Whenever you told innate immunity, automatically in your mind, what is the innate defense or immune defense to any injury is an inflammation. So IL-1 is that much important. The machinery which is generating IL-1 itself is called inflammasome. Okay. So what is inflammasome? Inflammasome is a multi-protein complex. So it has a variety of proteins and they come together and they activate an enzyme which is known as caspase-1 enzyme. Okay. So inflammasome is a combination of proteins or multimeric protein in cytoplasm. They activate caspase-1 enzyme, and this caspase-1 enzyme finally activate the IL-1 beta and IL-18 from its pro form. Initially, we have IL-1, IL-18 in its pro form. Then this inflammasome, through this inflammasome, this organ, that is protein organ, they created the caspase enzyme, an enzyme which cleaves the phosphatase enzyme, which activates the pro IL-1 or pro IL-18 to active IL-1 and IL-18. So let's see how many types of inflammasome we have. So we have NLRP3. This NLR means not like P3 inflammasome. So understand, we have innate immunity. In innate immunity, we don't have receptors, normal receptors. Like in B cell, we have B cell receptor. In T cell, we have T cell receptor. Innate receptors commonly is called as sensors or innate sensors. Among the innate sensors, we have toll-like receptor, ring-like receptor. Same way, we have knot-like receptor also, which is present in cytoplasm. So NLRP3 is an inflammasome which is using the knot-like structure, that is NLRP3, called as NLRP3. Another other inflammasome also there, that is known as NLRC4, then AIM2, AIM, absent in melanoma, AIM means. See, these two inflammasomes are also there, but difference is that these inflammasomes are highly specific. And whenever you are talking about the innate immunity is all about non-specificity. So NLRP3 has a very broad level of activators, means NLRP3 are sensitive to very broad level of stimuli. Oh, but these two or variety of other inflammasomes, they are little bit specific for some certain stimuli. Okay. So inflammasome is a cytoplasmic protein which is essential for the creation of active IL-1 and IL-18. Okay. So how this work? So you have two things. That one thing is a priming. So what is priming? Suppose there is an inflammatory malleoli nearby. This is a cell. A cell is trapped inside the inflammatory malleoli, already inflammatory malleoli. So this inflammatory malleoli, they stimulate this innate sensors, stall-like receptor, nod-like receptors. They go through, they activate some transcription factor that is called as nuclear factor kappa beta. And nuclear factor kappa beta start making NLRP3 NLRP3 plus pro IL-1 and IL-18. This is not active IL-1, IL-18. Means you need another signal which will activate it. So this the second part is known as activation part. First part is priming. Means so your immune cell is around the inflammation. That cell become primed. Primed cell, they already make NLRP3 and pro IL-1 and IL-1 alpha, IL beta or IL-18. So the second signal is a broad signal. So anything which is PAMP means pathogen associated molecular patterns. What molecular patterns pathogen associated? So they can it can be activated through peptidoglycan or or lipopolysaccharides or through DAMPs. What is DAMPs? DAMPs is a danger associated molecule. Inside the cell, there are many molecules, which is not important for our serum. Suppose this cell is burst and all this comes in a serum. So this is called danger associated molecule, danger molecules. So ATP is for inside the cell, not in the serum. Uric acid, crystals, reactive oxygen species, iron flux. So potassium, excess potassium, extracellular potassium. ATP, acidic medium, crystals. What crystals? Any crystals. What kind of any crystals? Monosodium urate crystals in gout. Then calcium pyrophosphate crystals in pseudo gout. Then your cholesterol crystals in atherosclerosis. Then amyloid crystals in your Alzheimer disease. So all these crystals can activate your NLRP3. So what are the components of NLRP3? Inflammasome. So NLRP3 is a sensor molecule which combined with ASC. This is a apoptotic spec like protein. You don't need to remember. Just remember this is protein number one. This is known as NLRP3. Protein number two. This is known as ASC. Then this is the enzyme, procaspase enzyme. Okay. So all three become this. They create a multimeric protein, and this from this multimeric protein, procaspase one to active caspase one develop. From the active caspase, that is fourth structure. Active caspase, they take out the inactive part from the IL-1 beta, then IL-1 beta becomes active, then IL-18 becomes active. This is there. But question is that IL-1 and IL-18, they are not stored in vesicles like other protein. Like TNF alpha IL-6, they body make it, then they trapped in the vesicles, then they exocytosis occur. So for other cytokines, you have proper Golgi body pathway that is known as Girel pathway. But IL-1 and IL-18 or IL-1 family doesn't have this vesicle. So how this IL-1 or IL-18 comes to the extracellular media? This is a good question. So this cell has to be break. Means there should be a break. So the IL-1 and IL-6 can come out. So how it breaks, we will see. So inflammasome priming, then activation, then procaspase 1 activation, Then procaspase 1 leads to the activation of IL-1 beta and 18, and there is something happening through which cell died, and this activated IL-1 beta and 18 comes into the cytoplasm. So because of this, you can understand this cell is died here. So this is a death, and you are having some caspase enzyme here. But programmed cell death apoptosis is mediated through caspase. So caspase is also here. Death is also here, but this is associated with inflammation. So this is called pyroptosis. So inflammasome is important for IL-1. IL-1 secreted through in pyroptosis process, and IL-1 itself a pyrogen. Okay. So important point. Two signal pathway needed. First, this inflammatory malleoli. Then inflammasome activate the your principal enzyme, caspase 1. Then caspase 1 activates the pro IL-1, IL-18. Then inflammasome cause release of this IL-1 and IL-18 through inflammatory cytokines. So this now discuss the component of NLRP3. Okay, this is not NLRP3. This is no NLRP3 has three structure. One is known as pyrene domain, then NACH, NACTH, then leucine-rich repeat. This is not important. You just remember this. This NLRP3 has pyrene domain. So, and this NACH is for the recognition of signal. Suppose any signal comes. So this NACH become activated and they attach with another NACH. So two NLRP3 attached through NACH pathway. Then it becomes activated in LRP3. The second part is known as ASC, na? That is adapter protein. What is ASC? ASC is apoptosis associated stick-like protein. So ASC also has pyrene domain, if you see here, and it has a CAR domain. So once this NLRP3 becomes activated through different signals, this pyrene interact with this pyrene. So these two becomes, the two attached each other. So now NLRP3 and ASC now here. In ASC, we have procaspase enzyme. This procaspase enzyme is recruited through this, and ASC has a CAR domain. What is CAR domain? CAR domain is caspase recruiter domain. Na? So, pyrene attached to the pyrene, then this CAR domain recruit or all procaspase 1 here. Once procaspase 1 here, then they start autocatalytic unit. So they start catalyzing autocatalytic unit. So procaspase 1 become activated. So important thing is NLRP3 has a pyrene domain, adapter has a pyrene domain. Okay. Another adapter is card. So you see, suppose you have a gain of mutation in pyrene gene. So your NLRP3 pyrene gene or any pyrene part of any inflammasome, they do not need any activation from any side. So this pyrene will automatically become activated. This pyrene once become activated, they attract adapter protein, then caspase 1, then ongoing inflammation. So if you have pyrene mutations, gain of function mutations, suppose pyrene is constantly activated. Normally you need activation signal. Before activation, you need NLRP3. And NLRP3 has developed from the priming. That priming was inflammatory malleoli. Okay. So this is there. Just go once here. What is card? Card is a caspase recruitment domain. What is LLR? This is a leucine-rich repeat. See, this NLRP3 in cytoplasm, okay, that is there. Then this NACH, this is a nucleoside binding domain. No? So this attached to the something, then they uses the ATP, then two NACH become, they attach together. Okay, so this is occur. So now two signal model of NLRP3. You need priming. How will you get a priming? Through inflammatory malleoli, through TNF alpha, toll-like receptor, another thing. What we got, what is the result of priming? Through priming, you suppose toll-like receptor activated, nuclear factor kappa beta activation, they created transcription of NLRP3 and IL-1 and IL-18 in pro form. Then signal 2. How signal 2 becomes activated? Broad signals, crystals, cellular injury. Through cellular injury, it can activate it through ATP or potassium or reactive oxygen species or mitochondrial pathways. And then they can release it can be activated through particulate matters like silica, asbestosis. So different ILD have NLRP3 activation. So for activation of NLRP3, priming is needed for the formation of NLRP3, and activation is needed for final release of these two. So how NLRP3 become inflammasome? Because NLRP3 is a sensor. So this is NLRP3 oligomerization. Once your NLRP3, I told you, once it becomes activated, they two attach through Natch domain. So they comes together, this activated. And once they're activated, they because they have a parent domain. Here they have a parent domain. So this parent domain attached to the ASC protein. So there is a recruitment of ASC through parent-parent interaction. So first is NLRP3 activation, then homotropic interaction of parent-parent. Then third one is a card. Once your parent activated, then this card becomes activated. Then this card attract your procaspase 1 through card. So card-card interaction. So parent-parent interaction, card-card interaction. Now finally assembly. This is spoke-like structure created. This is called spec-like structure is created. This is called inflammasome. Once inflammasome is there, then autocatalytic unit here start functioning and they start secreting caspase 1. So caspase 1, what caspase 1 is doing? Caspase 1 is activating IL-1, IL-18. That is okay. But I told you how this IL-1 and IL-18 comes out. So there is another molecule that is called gas dermin D. Normally, gas dermin D is not lipid soluble. So gas dermin D, they also cut this gas dermin D into N terminal and C terminal part. This N terminal comes and fused to the cytoplasm and they created pore or they inserted they punch a spore here. So once spore is there, then your final cell swelling, membrane rupture, everything release process is called paroptosis. So outcome is release of IL-1, IL-18 and TNF alpha. So these are the rheumatological relevance we will see. So summary is this: any danger signal, NLRP3 activation, inflammasome assembly, caspase 1, then release of IL family, then this is called paroptosis pathway. So now discuss about the IL-1. IL-1 family has 11 cytokines. IL-1 family has 11 cytokines. IL-1 family is not working through JAK pathway. IL-1 family can be divided into it can be divided in two parts: pro-inflammatory cytokines and regulatory cytokines. Pro-inflammatory cytokines are like IL-1 alpha, IL-1 beta, IL-18, IL-33, IL-36. IL-33 is important in TH2 type 2 immunity, that is TS2 mediated pathway. IL-18 is important in macrophage activation syndrome. IL-1 is important in different autoinflammatory syndromes. Then nature has created its own regulation because you need control on inflammation also. So IL-1 family also has a IL-1 receptor antagonist, natural antagonist. Normally we are making monoclonal antibodies, but IL-1 itself in family, there is a natural antagonist that is known as IL-1 receptor antagonist. Similarly, IL-36 also inflammatory cytokine. So its antagonist is IL-36 receptor antagonist. Then 37, 38. Important is you just remember these two: IL-1 receptor antagonist, IL-36 receptor antagonist. So suppose you have loss of function of IL-1 receptor antagonist or IL-36 receptor antagonist. So there will be autoinflammatory disease. Here, suppose you have gain of function in parin, then you have high IL-1, IL-18, that is autoinflammatory disease. If you have less this cytokines, you have autoinflammatory disease. What are the biological functions? We will see, but everybody knows from our 10th, IL-1 is important in fever. Okay. So fever, inflammation, nucleosides, we will see then clinical importance. What all autoinflammatory diseases in in our rheumatology, autoinflammatory diseases like then gout, adult onset cell disease, systemic esophagia, CAPS, we will see. So I told you there is 11 family of IL-1 receptor. IL-1 cytokines, then receptors, because IL-1 has to work with receptor. Normal physiology is this: in neurology or endocrinology or immunology, there is one ligand. In endocrinology, this ligand is known as hormones. Okay. In neurology, it is known as neurotransmitters. In rheumatology, it is known as cytokines or interleukins. So there should be a one ligand. Then ligand should bind to its receptor. So like in endocrinology, you have different receptor. Neurology, you have different receptor. Here you have a different receptor. So receptor is very important value. Then once ligand bind to its receptor, then dimerization of receptor will occur. Then from its cytoplasmic path, some adapter protein will come, then some enzyme will cleave some inactivated transcription factor to activated transcription factor, then transcription factor will go inside the nucleus, then result is relevant relevant protein synthesis or cytokine synthesis. So let's see the IL-1 receptor, because IL-1 ligand we have discussed how IL-1 secreted, how IL-1 formed, caspase 1 how important. So this receptor has extracellular domain, that is for the ligand binding, then transmembrane domain, that is for the stabilization of receptor, then cytoplasmic domain, that is for downstream signaling. So this IL-1 receptors extracellular domain has three immunoglobulin-like globules. You do not need not to remember. This is not so clinically. This is important clinically, but not. This is deeper immunology. So you have three immunoglobulin. Among three, top two are the ligand binding site for these inflammatory cytokines. Okay. Then in the down part, here is a transmembrane domain anchor. Then there is is cytoplasmic domain that is known as TIR, TIR domain. TIR domain means tall like receptor, IL-1 like receptor domain means TIR. It's directly telling is signaling part of IL-1 is itself like a tall like receptor. So here again you understand IL-1 is a pure innate cytokines. So its receptor is also TIR. And it's work through its receptor. Just so extracellular domain, this is for the binding, then cytoplasmic domain for the downwards signal. Let's see. So what happens? This is our ligand, IL-1, IL-1 beta. So it binds to its receptor, where immunoglobulin part. Then this receptor has to recruit another thing, another part of receptor that is known as accessory protein. So IL-1 receptor forms a heterodimer with IL-1 receptor accessory protein. So the step two is a recruitment of a receptor accessory protein. Then finally heterodimer form. This what this heterodimer why this is important, because then stabilization of ligand. So these two receptors come together, both has cytoplasmic domain of TIR. So TIR domain again homotropic interaction here. So homotropic interaction leads to downward signaling. So here, importance of heterodimer. Stabilization of ligand, then two TIR domain comes together. Then once they comes together, they scaffolding is occur. So there is a space for adapter binding. Once the adapter binds, then downward signaling start. What is the adapter protein for toll-like receptor? This is important. For toll-like receptor, it is MID88. Even in the research, MID88 inhibition also in the pipeline. So IL-1 receptor also work through MID88. So MID88 is known as myeloid differentiation primary response protein 88. So see, this is a bridge. How this two toll-like receptor binds to one MID88. Once MID88 bind, they start activating downward transcription proteins that is known as IREC4, IREC1, TRAP6. What is IREC? This is interleukin 1 receptor like activating kinase, then interleukin 1 like kinase, then TNF like kinase. So this is known as all these 416, IREC4, IREC1, and IREC6 like inflammasome. This is called midosome. So in IL-1 comes bind heterodimerization of receptor with accessory protein. Through accessory protein is this accessory protein, then two TIR domain comes together. What is TIR? This is cytoplasmic part of receptor. Then these two binds to the MID88, and then MID88 recruit IREC4, IREC1, TRAP6. This all complex is called midosome. So midosome, once the midosome complex form, you just need midosome. So IL-1, then TIR domain, then midosome. Midosome leads to the nuclear factor kappa beta activation. Factor kappa beta activation through MAP kinase, which is a growth factor actually. They form different cytokines. What is important? Different cytokines. They forms IL-1 start helping TNF alpha, IL-6, IL-8, COX-2, and adhesion molecule. TNF alpha is another important pyrogen, and IL-6 is also inflammatory cytokines. IL-8 is important for the chemotaxis of neutrophils. COX-2 is important for the formation of prostaglandins in short-reacting proteins like leukotrienes. This is important now because of these leukotrienes, patient has arterial lesions also, wheal lesions in autoinflammatory diseases through COX-2. Then different adhesion molecules we will see. The key message is MyD8 is a central adapter that links IL-1 receptor activation to IRAK4 1 TRAS6, forms the midosome complex. Midosome complex leads to the nuclear factor kappa beta activation that leads to the MAP kinase that leads to the inflammatory gene transcription. Then signaling. I told you, I already thing, Cap. What is outcome? Outcome, once this nuclear factor kappa beta, always remember nuclear factor kappa beta will lead to the ITNF alpha, IL-6, chemokines like IL-18, addition molecule like P-selectin, E-selectin, COX-2 for the inflammation and for the urticaria, acute phase reactant like CRP, ASA. So any inflammatory disease, autoinflammatory diseases, you have all these things. Then it comes to the IL-1 family. We know level cytokines are there. We have but IL-1 alpha, IL-1 beta, simple thing. No? IL-1 alpha are present in everywhere. IL-1 beta only in immune cells. IL-1 alpha is needs don't need inflammasome. IL-1 beta needs inflammasome. This is IL-1 beta important in systemic inflammation. This is alarming. What it means? IL-1 alpha is do not need activation. It is already activated and present in the cytoplasm, in vesicles, in cytoplasm. So once the cell death is a cell injury is there, it will release. So it react like a alarming. Means any cell death is there, IL-1 alpha will release because it doesn't need inflammasome pathway. But IL-1 beta will release only if there is a activation, this inflammasome. So this is a difference. No? Priming signal, I told you priming signal, different damp molecule, then activation signal, same thing. Caspase 1, activation, release, gas Germany. So, effect IL-1 receptor, IL-1 important in inflammation, we know. So, local effect of inflammation, this is endothelium. Okay. For any inflammation, you need the WBC or immune cells come into the site of inflammation. So for this chemotaxis, you need to bind this. You need some breakage here. Na? So this is called adhesion molecule. This adhesion molecule leads to the attachment of these cells into the endothelium. So IL-1 increases the ICAM-1 intracellular adhesion molecule, VCAM-1 vascular cell adhesion molecule, E-selectin, leukocyte recruitment, vascular permeability. So ultimately, it increases the inflammation. Then it is also secretes the IL-8 and GCSF, so it enhances the neutrophil migration activation, and it also leads to the neutrophilic activation, which leads to the release of reactive oxygen species. IL-1 can in a local, it can cause pannus formation or synovitis, it can damage to the cartilage, it can cause osteoporosis or bone death through rankle, through osteoclast, rankle, or all these things. Systemic effect, it can affect on the brain. So hypothalamus, it can increase the set point. So fever, fatigue, sickness behavior, pain sensitization. It can go to the liver and form the acute phase reactant like CRP, serum amyloid protein A, fibrinogen. So bone marrow, it can increase the formation of different WBC. And IL-1 is a catabolic cytokine. So it can induce the protein loss of fat metabolism. That's why the chronic autoinflammatory diseases, patients are cachexic also. Before treatment with steroid, patient can become obese, but usually in a chronic inflammation, any chronic inflammation, you have this IL-1 and TNF alpha also, but they are catabolic chemicals. So they break down all this, your proteins, fat breakdown, weight loss, everything. Then can IL-1 affect on adaptive immunity? So you can see the function is locked for local effect, then for systemic effect, then for your adaptive immunity. So IL-1 can promote the polarization of T cell to Th17 cell. Just see one thing. Th17 secretes IL-17. IL-17 also enhances the IL-8. That also enhances the neutrophilic infiltration. So somehow IL-1 is touching that part of adaptive immunity that also increasing neutrophilia. So IL-1 itself increases the neutrophil or recruited the neutrophil. And IL-1 through adaptive immunity via Th17 recruit the neutrophils. So this is there, the amplification loop. Here, chronic damage is there, chronic inflammation there, continuously IL-1 is there. If IL-1 is there, then IL-1 can transform this T cell into a T cell into the Th17 cells, and then Th17 cell leads to the IL-17 and further release. So this is auto amplification. So this is there. So patient will have in autoinflammatory diseases, the patient will have joint pain because patient, IL-1 has a tendency to damage the cartilage and synovium. Patient will have fever, definitely, because IL-1 is a pyrogen. Patient can have urticarial lesions because IL-1 continuously express the COX-2, which leads to the prostaglandins as well as leukotrienes. These leukotrienes can leads to the can leads urticarial lesion. IL-1 disease can have another mechanism. It increases the acute inflammation. So histamine, bradykinin, all these things also releases mainly histamine, not bradykinin. Okay. Then come to the clinical picture. This is most exciting part. So NLRP3, this pathway, any danger means either genetic continue activation or through crystals. So, crystal arthritis or autoinflammatory diseases, NLRP3 activation, caspase activation, IL-1 release, all these features. So, gout is a mono to oligoarthritis. So, gout is a inflammasome disease. CPPD is a inflammasome disease because these are crystals. Crystals activate your primed cell. Then monogenic diseases. Suppose we have mutation in parengenes. So you can have CAPS. CAPS is not catastrophic APS. It is a cryopyrin associated periodic syndrome. Why this is occur, we will see. Then we have different disease in which patient has osteitis, periosteitis, that is DIRA. DIRA is a deficiency of interleukin 1 receptor antagonist. Then we have DITRA, deficiency of interleukin 36 receptor antagonist. See these two things. These inflammatory diseases, they more behave like a psoriatic spectrum disorder. So periosteitis, pustulosis, severe generalized pustulosis, periosteitis. Why? Because I told you IL-1 can activate IL-17. So they can dominate the IL-17 dominant clinical picture could be IL-17 dominated disease. So pustulosis, periosteitis, osteitis. Then through continuously COX-2 patient, you can have urticarial lesions also. So these are the diseases. So we have diseases like Papa syndrome, PFA-P8 syndrome, different Majid syndrome. So these autoinflammatory diseases are here. Then systemic diseases. In systemic diseases, we have systemic onset GIA, although it is called still disease. Adult onset still disease and systemic GIA together now called as still disease. What are the pictures of still disease? Definitely fever, fever, fever. So high spiking fever. Quotidian fever is there. Why rash? Because permeability, whenever inflammatory this fever, whenever there will be the fever, there will be high IL-1, so there will be more vascular leak. More vascular leak will lead to the rashes. Cartilage and synovium leads to the arthritis. Through liver, marked inflammatory cytokines. Okay, then idiopathic recurrent pericarditis can be due to can be common in autoinflammatory diseases. This is also there, and partially it can also involve in the Behçet disease. So these are the different manifestation of IL-1. So diseases that taught us the importance of IL-1. How we understand IL-1 more. CAPS. So we know that once you have a gain of mutation in NLRP3, result in excess IL-1 production, causing recurrent fever, urticarial rashes, arthritis, hearing loss, and systemic inflammation. So what is the mechanism? NLRP3 gain of function. Finally, all these things. Second thing is a DIRA. DIRA is a deficiency of interleukin receptor antagonist. So loss of natural IL-1 receptor antagonist leads to, because IL-1 receptor antagonist is not there. So upregulated IL-1 signaling. This is not NLRP3 mediated. Upregulated IL-1 signaling. So IL-1 continuously IL-1 excess IL-1 beta is there. Excess IL-1 beta will lead to the IL-17 also. This IL-17 will end up into the severe periosteitis, osteitis, pustulosis, and inflammation. So rapid and life-changing response to the IL-1 blockage. In this case, we see. Then DITRA, 36 receptor antagonist. Again, same thing, 36 receptor antagonist generalized pustulosis. Then gout, monosodium urate crystals, we understood, then Sogia. In Still's disease, now treatment is coming towards early introduction of early IL-1 or IL-6 inhibitor in the case of Still's disease. So Still's disease macrophage lead. Still's disease is a combination of all macro. Suppose patient is impending towards the macrophage activation syndrome. It's better to start IL-1 early. So what they found rapid fever resolution, dramatic steroid sparing, prevention of chronic disease progression, and effective mass control. So we have three types of IL-1 inhibitor. You can block IL-1 receptor IL-1 molecules directly. So you have anakinra. Anakinra is a receptor antagonist. So IL-1 receptor antagonist. Here Ra means receptor antagonist. So anakinra will block both IL-1 and IL-1 alpha and beta. Then a canakinumab. I told you no means monoclonal human, fully human monoclonal antibody against IL-1 beta. Then we have rilonacept. Rilonacept, this important word is sept. Sept means receptor. So this is an artificial IL-1 receptor. This is causing IL-1 trap. Means they are sinking all the IL-1. Here you are blocking the receptor, that is anakinra. Another thing, you are blocking the molecule, that is canakinumab, that is selective. Then you can trap the IL-1 through artificial receptor, that is known as rilonacept. Another IL-1 receptor antagonist is zivokizumab. That has been tried in uveitis also, but commonly drugs are anakinra, canakinumab, and rilonacept. Problem with anakinra is dosing. Dosing is daily. You have to give frequent dosing. For canakinumab, you can give into from 2 weeks to 4 weeks also. 4 weeks mostly in 1 month also. And rilonacept 1 or 2 weeks. So let's see what is happening. Suppose you this is CAPS. What is CAPS? Cryopyrin associated periodic fever. So what is the genetic problem? Genetic problem is gain of function of NLRP3, gain of function of NLRP3, gain of function of NLRP3. So FCAS, familial cold autoinflammatory syndrome. FCAS is minor problem, not minor, mild. Muckle-Wells syndrome is moderate. NOMID is neonatal onset multi-system inflammatory disease, is severe disease. So age of onset, usually it's minor to childhood or adolescent. Childhood, adolescent is very severe. It come itself is in a even prenatal stage also. Trigger is cold exposure, none. Then clinical feature. This is you see urticarial rash. I told you how you can explain Brooke urticarial rash, fever, arthralgia. Okay, all these symptoms are there. So you can see so all these things are there. So you just remember the name. So canakinumab approved medication is for up to 1 week. Rilonacept weekly. Anakinra almost daily. Colchicine, because colchicine inhibits the NLRP3. Just remember one thing. So colchicine can work here. Here, anakinra, canakinumab, rilonacept. You can use also. So this is there. Then you come this other autoinflammatory diseases like HITS. HITS means hyperimmunoglobulin D with periodic fever. These are periodic fever syndrome. And we go one by one. HITS, TRAPS, and MMF. MMF is familiar Mediterranean fever. So except HITS, TRAPS, and familiar Mediterranean fever are autosomal dominant. Okay. Here, a mevalonate gene mutation is there. Here, your TRAP gene is there. Here, mevalonate gene mutation is there. To prove, just important thing I will tell you, maximum chances of amyloidosis with familial Mediterranean fever. Okay. MEFE gene mutation we need to see. Respond to the colchicine. In the traps, traps due to the TNF receptor dysfunction. So you can't give etanercept here. Sorry, you can give etanercept here. Okay. Then all these things are there. Hyper IgD is doesn't mean always hyper IgD itself. You can have hyper IgG also. These are the different autoinflammatory disease, Still's disease, Sjogren-Lawrence disease, DIRA, Papa syndrome, then blistering pyoderma gangrenosum. This is known as BPG. Then SNOMID. SNOMID is severe neonatal problem. All these things are the and Papa syndrome. I just want to tell you. fever, pustulosis, osteitis, young age, unexplained, not fitting into the any diagnostic criteria. It could be the autoinflammatory diseases. Okay. Then autoinflammatory, there is a trial. This is known as CANTOS trial. CANTOS trial showed कि canakinumab is significantly CANTOS trial provide the first large clinical study that show the NLRP3 IL-1 beta not contribute not only to the rheumatic diseases but also the atherosclerotic diseases. So what I'm telling you, IL-1, how chronic inflammatory diseases is causing CADs. One of the reason is through inflammation. Okay. So these drugs we have discussed. So the thing new is there. Once again, anakinra, this is a receptor antagonist, so will you block both. Canakinumab, you block the IL-1 beta specifically. Then rilonacept is the artificial receptor. What are the future drugs? You can block the NLRP3. I told you one drug is colchicine that also blocks the NLRP. Okay. And IL-18 inhibitor is a tadecking alpha. Another thing is IL-18 is also used as a marker, biomarker, now increasingly used in the marker in Still's disease and MDA5 myositis. So this is a final summary of the IL-1. So main thing is that different diseases we understand through NLRP3. So through this chapter lecture is over. Veduji, if any question, please let me know.
Uh, Thank you so much, sir. It was a very valuable session. And thank you, Dr. Tiwari, for such a masterfully put together session. And we really
Thank you.
appreciate you, sir, for sharing your deep expertise in clinical immunology with us. So we just now open the session for any questions. And with your permission, I'll
Ah,
just share some few questions that we have in our chat box. Um, so the first question that is coming up, that is, what rheumatological diseases have strongest evidence for inflammasome involvement?
inflammatory involvement, famous example is right, left, center. That is gout. Gout is classical example of inflammation. Just 1 minute. I tell you, whenever there is a gouty attack, then you will see there is very severe joint swelling with patient will feel fever also. Means gout attack, while the attack of joint pain in the great toe, patient is having fever and the toe looks like a cellulitis. So it is a pure inflammatory disease, and that's why I told colchicine is a NLRP3 inhibitor, which is indirect, which means inflammatory inhibitor. That's why colchicine is effective in gout. We what we used to know tell ki colchicine with inhibit the neutrophilic chemotaxis. That's okay. But what is exact mechanism? Exact mechanism, it also inhibit the NLRP3. That's why it's effective in gout. So in the Indian setup, classical inflammatory disease is gout. But in Arab countries and Western countries, we have familiar genetic fevers also. Because of mutations, gain of mutations, these inflammation becomes unduly activated. These leads to the continuously periodic fever syndromes. That is due to genetic mechanism. So those genetic diseases also there. Fortunately, in our country, we don't have enough this genetic diseases. But I am not actively practicing pediatric rheumatology, so I don't know exactly the incidence in our India. But as far as my knowledge, this is rare. But these diseases are very dangerous diseases.
Okay, so thank you so much, sir, for the expertise. So there's one more question. This NLRP3 inflammasome, what do you think? Would early intervention in this pathway will reduce long-term joint damage?
No, this question definitely if we control it. Suppose we know what is gout. You just inflammation can be activated through two mechanisms. First, the genetic means always. Second thing is through episodes. So suppose like a gout, patient is eating something and uric acid release, suddenly it will come in the episode. So in that way, yeah, and definitely colchicine will help, but that way prevention is sufficient. Sufficient means suppose you control your uric acid, you are not giving any trigger to the inflammation, so disease will obviously in remission. But if you are unfortunate, you have genetic disease where the your auto this inflammation becomes auto activated. Definitely, that's the point. Through IL-1 inhibitor, these diseases were lethal. Now, almost they are achieving in many of the diseases, they are achieving very good responses. Very good responses. So we can prevent this long-term structural damage of joint and all others. Why we are now not using in RA? Because in rheumatoid arthritis we have many biologics which are more easier and available in India. So we are not using this. Second thing I told you, frequency is a matter with IL-1. So we don't need to use IL-1 too. But few diseases are there where IL-1 is definitely miraculous drug.
Thank you so much, sir. So, these were the few questions. If any more questions are there, sir, I request the participants, they can just put in the chat box. And the video, this webinar session will be available. The recording will be available on the YouTube. So, as per your requirement, you can just go through the session and just let us know if there's any more query. So, doctor will surely he will assist you for the same. So, with this, doctor, anything else you want to share with us?
No, thank you. If any questions, please give a message. I will answer. Thank you.
Okay. So, with this, with your permission, we just wrap on the session. And huge thanks to all the participants and Dr. Tiwari for this wonderful masterclass session. And we'll be soon coming up with the next session, and details will be shared to all of you. And thank you, Dr. Tiwari. Thank you, all the participants.
Thank
And we
you.
look forward
Thank
to
you.
see you very soon. Thank you so much, everybody.
Thank
Bye.
you. Bye.